Hello, my name is Seth. Thanks for watching my videos on YouTube at How I Think. And in today's video we're going to be talking about EIGRP, Enhanced Interior Gateway Protocol by Cisco. This is a Cisco proprietary routing protocol and is only used on Cisco equipment. So Cisco routers or Cisco Layer 3 switches. You can have other types of switches, Layer 2 switches, but Layer 3 and above would be all Cisco. EIGRP sends updates using Reliable Transport Protocol (RTP), and it has its own protocol that they created. It's called Protocol 88 or Protocol EIGRP to send updates. The beauty of EIGRP is that it's considered, depending on which book you read, some call it hybrid and some call it distant vector, but it has benefits of both link state and distant vector protocol. It can send partial updates to other routers, and it also takes into account the bandwidth and delay, and that's how it chooses loop-free routes. And so EIGRP uses 5 metrics to analyze and compute the best route. So it uses bandwidth, delay, load, reliability, and MTU. By default, only bandwidth and delay are used to compute a route, best route. The cost with the lowest metric is added to the routing table. That's how it works. So as you can see, I have a diagram in the background. We're going to be using 3 routers, router 1, 2, and 3, and router 1 and 2 are connected via a serial link, and by default the serial link uses 1.544 megabit speed or T1 speed. Router 2, 3 is using fast Ethernet, router 1 and 3 using fast Ethernet, which are 100 megabits. You can see the IP ranges that we're going to be applying and the loopback addresses. So we'll go ahead and get started. Okay, so I'm logged into router 1, as you can see. Right now I have nothing set up, so we'll go ahead and start setting this up. First thing we'll do is we'll go into configuration mode, and the first thing I'll do is set up my loopback. So loopback 1 for router 1, and the IP address that we're going to give this is 10.10.10.1 255. I know the diagram says /32, but I'm going to make it a /24. Okay. And now there's 2 interfaces on router 1, interface 1 and interface 2. Let's do this. There we go. So serial interface 1 and fast Ethernet 0. So let's go ahead and get into serial interface 1. Interface S1/0. IP address would be 172.16.12.1. 12. The reason I chose 12 is because this is between router 1 and 2, so 12. So this is 12.1, 255.255.255.0, no shut. Okay, now we're going to go into interface FA0/0, and that would be IP address, and this is 13.1 for router 1 and 3. IP address 172.16.13.1 255.255.255.0. Oh, what did I do here? Okay, no shot. Okay, so now we hop onto router 2. Well, let me put this in order. Okay, so now we're on router 2. We're going to get into config mode, and we're going to type interface loopback 2. IP address is 10.10.20.1 255.255.255.0. Now this is connected to serial 1 and 0, so we're going to get into serial 1/0. IP address is 172.16.12.1 .12.2 and no shut, and interface 0/0, IP address 172.16. This is, remember, 23.1. No shut. Okay, so now we're going to go to router 3 right here. Config T, interface loopback 3, IP address 10.10.30.1, interface FA0/0, IP address is 172.16.23.2. No shut, interface FA1/0, IP address 172.16.13.2. No shut. Okay, so now if I type show IP interface brief, and we can see that my IP addresses are all set up and everything is up. We can do the same thing on 2, and we are up, up, and up. And we're up, up, and up. Okay, so we have all the IP addresses set up. So now let's go ahead and set up EIGRP. So the first thing we'll do is I'll exit, and from the config mode we'll type router EIGRP, and we have to give it autonomous system number, AS number, between 1 and 65,000. We'll go with EIGRP 100. Here we type in network. We're on router 1. Now here's an interesting part about EIGRP. When you type in the network command, you're only enabling EIGRP on these interfaces. Okay? Nothing else. You're only enabling EIGRP on the interfaces. You're letting this router know by this network command that I want these interfaces, or however many interfaces, to participate in EIGRP. That's all. It doesn't impact network routes are set up or how the routes are distributed. It has nothing to do with that. It's only on the interfaces, how, if you want them to participate or not. We'll do all 3 of these different ways, so you get to see different ways of applying the network command. So here we're going to type network, and let's say we're going to do each one by one. Okay, so we can say network 10.10.10.1, right? 255, 255, 255, 255. That's one way. You can say network 172.16.12.1, 255, 255, 255, 255. This is a wildcard mask that you use, and we're going to say network 172.16.13.1, 255, 255, 255, 255. So remember I said I'm going to show you 3 different ways we can add the interfaces. Alright, so we're done here. I'm going to type exit. Now we'll go to router 2. We're on this router. We type router EIGRP. Now remember, the AS number has to be the same on all 3 routers, or however many routers we have in the system that you want this implemented on. Alright, now we're in the config router mode. Here we're going to type in network, and I'll show you a different way. Remember, in router 1 we did the exact match of the interface IP. On router 2 we're going to do the network, and we're going to do the subnet. So it's 172.16.12.0 0.0.0.255. See how this adjacency came up right away with router 1? And telling us it's a new adjacency, so it picked up all the routes from it. Now we're going to say network 172.16.23.0 forgot the subnet, that is a wildcard mask, 0.0.0.255. And next one is network 10.10.20.0 0.0.0.255. Okay, we'll hit exit here. So one way is to exactly specify the interface, the other way is to specify the subnets, and the third way on router 3, router EIGRP 100. The reason it's 100 is because it's in the same system, same area. Well, I shouldn't say area because that's OSPF, but it's in the same autonomous system, the same grouping. Here, we're going to say network 0.0.0.0, and this will include all interfaces. There you go. Now you should see adjacencies come up. Yep, here and here. New adjacency. So now if we go to router 1, we can see that it has 2 adjacencies. Router 2 has 2 adjacencies as well. Router 2 has 1 adjacency. Let's see. We did it on... Yep, 2. It has 2 adjacencies. So we're all set here as well. So now if I come back to router 1 and type exit, I type show IP EIGRP neighbor. If I can spell neighbor. N-E-I-G-H. Okay, so this is telling us that we have 2 neighbors established on router 1. One is to 13.2 and the other is to 12.2. This is 13.2, right? 13.2 here and 12.2. These are the 2 neighbor adjacencies that we have set up via Fast Ethernet 0 and Fast Ethernet 1 or serial 1. So hold time tells us, here I'm going to hit up arrow and you can see that it increments, see 12 and 13, and it goes back to 14, 12, 13, 11, see how it's changing, 10, 14, that's every 5 seconds or so. So EIGRP uses multicast to send hello packets, and that's how it discovers neighbors. And these hello packets are sent to a multicast address, which is 224.0.0.10. Remember, OSPF, if you remember, sends it to 224.0.0.5 or 6. I forget. And EIGRP sends it to 224.0.0.10. And it uses it, and it sends these hello packets using its own protocol. Remember, as I mentioned earlier, it's protocol 88. Okay, and so these hello packets include hold times and hello times. So hello times is 5 seconds and hold time is 3 times that, which is 15 seconds. So this is telling us that if you notice every 5 seconds this is refreshing, right? 11, 14, so you went back to 14, 12, 13, 11. So this is telling us that every 5 seconds it sends a hello packet saying, hey, how are you? I'm alive. Here I am. And within that packet, that hello packet, there's also a hold timer, and a hold timer is a 15 second, is 3 times the hello packet. That hold time says is, if I don't hear from you in 15 seconds, I am going to drop you from my neighbor. I'm going to drop you as a neighbor adjacency. That means you're dead. You don't exist. That's what it means. And then this is the queue count. If the queue count is 0, we're all good. That means everything is alright. But if it's 1, or anything else, that means one of the interfaces is not updating correctly and things are queuing up. I think that's what you need to look out for. So we can say show IP EIGRP topology, and topology will show us everything it has learned so far. So P means passive. P means everything is good. Everything is good. A means active. That means a neighbor adjacency has having issues on a router, on a link, and it's not updating itself correctly. And so if you see an A, if you see anything other than P, basically, you're going to see that queue count go up. That's what it means, okay? And remember I mentioned it uses bandwidth and delay as the default metric to choose a loop-free path. If we look at 12.16.23.0, which is down here, which is this link here, from router 1's perspective, it's telling us that there's two successors or two paths available to this, two loop-free paths available. Okay, one is via 172.16.13.2. 13.2, that means I can get to it from here to this network, this range. I can get to it from router 3, and I can get to it from router 2. If you look at it, between router 1 and router 2, we're using a fast Ethernet, which is 100 megabits, right? So it's saying that, hey, my administrative distance, or my feasible distance to this route here, on this route, is 30720. Okay, and router 2 is advertising that, hey, I am 28160. Okay, meaning this is my feasible distance to this network, and the reason is less is because if you look at it, router 3 is directly connected to the 23.0 network. That's why it's less, right? So router 1 says, hey, this is my administrative distance, this is my metric to get to this route. And router 2 says, hey, router 3 says, I'm closer, this is my metric. So that's why router 2 is a viable successor or loop free. That's why it's added first. Now serial link is a slower link. It's a 1.544 megabit. And if you look at it, router 1 is saying it's taking me 217.2416. That's the metric it has come up with to get to this range here. And router 2 then says, well, since I'm directly connected to this link here, that's why it's 28160. So because this is bigger than 28160, it's still a viable loop-free route, and so it added both these routes in here. But because 13.2 is a faster link, that's the first viable route it's going to use. That's why it's the first successor in the list, and the second one is the slower. Does that make sense? It's a slower link, so that's why it's the second one. So let's take a look at this. Show IP route. If we say show IP route, now to get to 23.0, see, to get to 23.0, remember in the topology here we have two ways to get to it, but 13.2 is the best route because it has a best bandwidth and delay. So guess what? Look, I put it into the routing table. Router 3, if we do show IP route, we have two routes to 12.0, and they're both, because they're both going through fast Ethernet 0, right? They're both going through fast Ethernet 0 to 20 from router 3. We're right here, fast Ethernet 0. The 23 route is here, and the 13 route is here. So they're both equal cost and equal bandwidth, so it placed both of those routes in our routing table. Why? Because it's equal cost. If we come to router 2, we don't have equal cost here, right? Because we have a slow link here, and so it's only going to put, remember, the metric. It looks at bandwidth and delay. It's going to take the lowest metric and put it into the routing table. So obviously, for on router 2, we only have one way of getting to 13.0, right? And the best way to get to it is through to 23.2, because it's fast Ethernet. It's much faster. On router 1, same thing. We have a slow link and a fast link. To get to 23.0, it chooses the lowest metric. Show IP route. And so it chooses the lowest metric, and it goes through fast Ethernet 0, 13.2. But router 3 is unique. It has two equal paths because both of them are fast Ethernet, and that's why both of them are placed in the routing table. So this is how EIGRP is set up. So let's go ahead and ping 10.10.10.1, 10.10.20.1, oops, ping 10.10.20.1, and ping 172.16.12.1, and success. So I'm able to hit all the routes. This in a nutshell is EIGRP. I hope this was a quick tutorial. My next video on EIGRP will be on auto summary, how to summarize addresses. And so stay tuned for that. I hope you enjoyed this video. Have a nice day.